In this video, I'm going to solve some questions under pH of strong acid and bases. Now, one thing I want you guys to understand is that you have to take note of how I'm going to be solving each question, the approach and the formula I'm going to use, right? Because it doesn't necessary for you to actually pass through a long method before you can actually solve pH. So it's very, very simple. Now, from this question, we are asked to find the pH, right? We are asked to find the pH. That's exactly what we are asked to find of 0.1 hydrochloric acid. That means that the concentration of hydrochloric acid is actually what? 0.1. I will know, if you look at this hydrochloric acid very well, whenever it's undergo dissociation, it's going to dissociate into what? Into hydrogen ion, right? Which is H plus, and also what? Chlorine ion. And in that case, 0.1 of this actually dissociates what? To give 0.1 of this, and also what? 0.1 of this, as you can see. Now, what I'm going to do here is that since we're asked to find the pH of 0.1 mole per dmq of hydrochloric acid, the pH is actually going to be equals to what? 1. And I'm going to explain how. Now, since the constant of hydrogen ion that you're seeing here is actually 0.1 at equilibrium, that's why the constant of hydrogen ion is 0.1, which is also the same thing as writing 1.0 multiplied 10 raised power what? Minus 1. That's what we have, and the same thing as writing 10 raised power what? Minus 1. Now, if I put it into pH equals what? Negative logarithm of what? Of hydrogen ion concentration, I'm going to have it what? To pH equals what? Minus log of what? Of 10 raised power what? Minus 1. That's what I'm having it to be. So it's very, very simple. This is this actually was log a raised power what? M actually. Right? It is log a raised power M. If you take a look at it very well, this 10 raised power minus 1, and I'm having log, right? This is going to be A. This 10 is A, then raised power what? Of M, which is actually what? Minus 1. So this log a raised power M is the same as writing what? M log A. That's what we have it to be. Right? So in that scenario, I'm going to have pH to be equal minus logarithm of what? Of, look at this, oh, this is 10 raised power what? Minus 1. Then I'm going to bring down the minus 1 actually. So if I bring down the minus 1, I'm going to have pH to be minus into brackets minus 1. Then I'm going to have log 10 base 10. Log 10 base 10 is actually what? 1. So I'm going to have pH to be equal. Minus multiply minus is going to be what? Plus. I'm going to have to be 1. And that's why the pH of the solution is actually what? 1. So that's what it. Now the next question we are having says, find the pH of 0.3 mole per dmq sodium hydroxide. Sodium hydroxide is actually it's actually a symbol of what? Of NaOH, right? And in that case, whenever we dissolve NaOH in what? Inside water, it's going to split into what? Into Na plus OH minus. That's what we are going to have. And since this stoichiometric ratio of all these reactants and products are the same, right? So that's why I'm going to have 0.3 mole of this, which dissociates to give 0.3 mole of this, and also 0.3 mole of this. But inside this solution, the hydroxide ion is actually the one that will affect what? The pH of the solution. So in that case, that's what I'm going to be using here. So from there, we can actually recall, right, the pH. We are asked to calculate for pH actually, right? That's what we are asked to calculate for. And pH is equal negative logarithm of hydrogen ion concentration. That's what we have it to be. So instead of wasting my time using any other formula, I'm still going to use pH plus POH equals to 14. I can actually make support of that as well. That's another formula. So instead of let me just say stressing myself, I can actually use directly pH equals to what? 14 plus logarithm of what? Of hydrogen hydroxide ion concentration, which is this. So that's what I'm going to use. If I'm using this formula directly, I'm going to have pH equals to what? 14 plus log hydroxide ion constant is actually what? 0.3. So I'm going to put 0.3 there. I'm going to have log 0.3. So pressing everything here at once on my calculator, let's see what I'm going to have. I'm going to have 14, right, plus log 0.3. That's what we're going to have here. So the answer is actually what? 13.4. So that shows that our pH is actually equals to what? 13.47 or 48 actually. So you don't need to say yourself. You can actually go ahead and apply this formula at once. Make sure you take note of the formula. It's very, very important. Like, take note of it. It's very, very important. You can actually apply it to question and get your answer directly. So that's just it. So now let's move to another question. So let's see the question that we are having here. The question says, find the pH. We are asked to find pH, right, of 0.05 mole per dmq of phosphoric acid. Phosphoric acid is actually H3PO4. This is phosphoric acid. Then whenever it's undergo dissociation, let's see what we are going to have. We are going to have it to be, let me say, this is going to be hydrogen ion. That's the first thing we are going to have, and also a phosphate group, which is PO32 minus, or simply you can use PO4 3 minus in that scenario, in this scenario actually. So from there, if you go ahead and balance the equation here, we have 3 hydrogen here. That shows that I have to add 3 hydrogen here, and by adding 3 hydrogen, that shows that the equation is actually balanced. So from here, we are having 0.05 concentration of phosphoric acid. That's that 0.05 of this guy here. No, this is actually 1. It has 1 mole of this guy, which is actually we have it to be approximately 0.05 concentration, right? It's going to undergo dissociation to give 3 multiplied by 0.05 of this hydrogen ion, and also 0.05 of this phosphate ion. But in this case, this hydrogen ion actually is the one that is going to determine the pH of the solution, because it's actually hydrogen is a factor that can be used to determine the pH of that solution. Now from here, since we are asked to calculate for the pH, what we are going to do is just to record the formula directly. We are already given that hydrogen ion concentration is actually 3 multiplied by 0.05, and that's going to give us 0.15 mole per dmq. That's what we're going to have it to be. So then we're going to record pH equals to negative logarithm of hydrogen ion concentration. That's what we have. Then from here, we're going to have pH to be equal negative logarithm of 0.15. Then from there, what's going to be our pH if we press this on calculator? We're going to have pH to be equal to what? So let's go ahead and do this. This is going to give us 0.82. You press on calculator. So that's going to be our pH. By pressing, when you press on calculator. So that's just it. It's very, very simple. We are going to have to 0.82, and that's just the answer. So if you enjoyed this video, don't forget to like, share, and also subscribe. Then let's move to another question. So let's take a look at the question that we have. The question says, find the hydrogen ion concentration of a solution of pH 4.352. It's very, very simple. Let's just go ahead and do this. We're already given the pH to be equal, right? 4.352. That's the pH. And we are asked to find the hydrogen ion concentration. So that's what we are asked to find. So you don't need to stress yourself. You can just go ahead and use this formula. Hydrogen ion concentration, right, is equal 10 raised power minus pH. So it's very, very, very simple. You can just go ahead and apply this formula. It's very, very direct. So we're going to have hydrogen ion concentration to be equal 10 raised power minus 4.352. Then we're going to have the concentration of hydrogen ion to be. Let me see if we press calculator. You're going to have 10 raised power. Just press this logarithm. Then you're going to have minus 4.352. So this is going to give you 4.44 multiplied by 10 raised power minus 5. That's going to be the hydrogen concentration. So you're going to have this to be 4.45, then multiplied by 10 raised power minus 5. So that's the hydrogen ion concentration. So it's very, very simple. Now let's move to another question. The question says, what is the pH of a solution whose hydroxide ion is 0.03 molar? So it's very, very simple. The formula you're going to use here is going to be pH is going to be equal. We're going to have this to be 14 plus log hydroxide ion concentration. So this formula you're going to use. Make sure you take note of the formula. So I'm going to put hydroxide ion into this formula. Let's see what we're going to have. We're going to have pH to be equal 14 plus log. This is going to give us 0.003. Then you can just simply press calculator. You're going to have pH to be equal 14 plus log. Let's see what is going to give us 0.03. Let me just put it as 3 multiplied by 10 raised power minus 3. Let's see what we are going to have in this case. So pressing calculator, we're going to have 14, then plus log. We're going to have this to be, that's going to be 0.003. Let's see what we're going to have. We're going to have this to be pH equal 11 point what? We're going to have 48. That's what we have as pH. So that's just it. Now let's move to another question. The question here says a solution has a pH of 5.0. The pH we are giving here is actually 5.30. Then what is its hydrogen ion concentration? So we are asked to calculate for what? Hydrogen ion concentration. That's what we are asked to calculate for. So from here we can simply say concentration of hydrogen ion is going to be equals to 10 raised power minus what? pH, right? If you recall the formula, they're going to have concentration of hydrogen ion concentration equals to 10 raised power what? Minus 5.30. Then let's see what we're going to have. We press this on calculator. We're going to have concentration of what? Of hydrogen ion, right? To be equal. This is going to give us 5.0. Then multiply by what? 10 raised power what? Minus 6. We're going to have it in what? In mole per dmq. So that's going to be our what? Our answer to this question. So that's just it. Now let's take the last question I'm having here. This is going to be the last question I'm going to solve under pH. Find the hydrogen ion and hydrazide ion in 0.02 molar H2SO4 and also 0.005 molar NaOH. First thing is just for us to listen to instruction. What are we asked to find? We are asked to find the concentration of what? Hydrogen ion, right? And also we are asked to find that of what? Of hydrazide ion, right? And we are given this concentration, right? So that's what we are given. So first thing I'm going to do is just to go ahead and do this. Look at this. I actually have to bring out a formula that actually relates these two concentrations together. And the formula is actually concentration of hydrogen ion, then multiply that of what? Hydrazide ion is going to be equal to what? 10 raised power minus 14. And if I'm asked to calculate for hydrogen ion, right? I'm going to have it to be 10 raised power minus 14 divided by what? Hydrazide ion. You have to take note of what? Of all this formula. And if I'm asked to calculate for hydrazide ion, I'm going to have it to be equal to what? 10 raised power minus 14, right? It's minus 14, right? Divided by what? That of hydrogen ion concentration. Now, from the first question, the what we are given here is actually what? H2SO4, right? And H2SO4 is what? Is an acid. So from here, if H2SO4 dissociates, right, it's going to dissociate into what? We're going to have H plus, right, plus what? Plus XO4 2 minus. And if you choose to what? Balance the equation, no, we're going to have everything in what? In aqueous state actually. It's very, very important to indicate the aqueous state. Now, look at this. If we actually balance the equation, we are going to add 2 here. And I think the equation is what? Is balanced. So that's so that we have 2 mole of what? Of hydrogen ion that is produced in this case. So, and from the concentration, that's so that this is 1. The ratio here is actually 1:2:1. And what it implies is that we are going to have 0.02 mole of what? Of H2SO4 that actually produce to multiply what? 0.02 molar of what? Of hydrogen ion, and also 1 multiply what? 0.02 molar of what? Of SO4 minus. That's what we are going to have. So from there, that shows that the concentration of what? Hydrogen ion is actually 2 multiply 0.004, 0.02. That's going to give us 0.04. Actually, that's what we are going to have. We're going to have to be 0.004. That's the constant of hydrogen ion that we're going to have. Then let's proceed to solve for what? Hydrazide ion. So if you recall, hydrazide ion concentration is going to be equal. From here we're going to use this formula, right? Since we know the hydrogen ion concentration. So we're going to have hydrogen ion concentration equals to what? 10 raised power what? Minus 14 divided by what? Hydrogen ion concentration is actually what? 0.04. So you can actually write this as look at this. You can write as what? As this is going to give us 1. Look at this. 1 multiplied by 10 raised power what? Minus 14, right? Divided by, look at this. I'm going to have 10 raised power what? Minus 2 here. Then I'm going to have multiply by what? This is going to be over 4. Right, that's what I'm going to have, because this is actually 4 times 10 power what? Minus 2. That's what I'm having. So from there, I'm going to have 1 over 4. Then multiply what? 10 power what? Minus 14. Then I'm going to have plus 2. So I'm going to have 1 over 4. Then multiply what? 10 power what? This is going to give us minus 12 actually. Right, so that's what we are going to have. So let's go ahead and erase this side so that I can actually solve the final answer there. So from there, look at this very well. So 1 over 4 is actually going to give us, I think that's something about 0.2 actually, right? So we have to 0.25. That's actually 1 over 4. So we're going to have this to be 0.25. Then multiply our 10 to the power what? Minus 12, right? And this approximately is 2.5 times 10 to the power what? Minus 13. So that's what the constant of hydrazide ion, right? That's considered what of hydroxide ion in molar. So, and this is considered what of hydrogen ion, right? So that of hydroxide ion is actually what 2.5 multiplied by 10 raised by what minus 13 molar. Now let's go ahead and solve for the NaOH, which is the second case. So let's see what we're going to have in that case, right? So if you take a look at this very well, we are given NaOH, right? NaOH, whenever we dissolve it in water, is going to give rise to what? It's going to dissociate into what? Into Na plus what? OH minus. And in that case, they will also exist in what? In nature state. And here we are having what? 1:1 is 1:1. That's what we have. That's what we're going to have 0.005 molar of this to produce 0.005 of this, and also 0.005 of this. So since this is hydrogen ion, that's at equilibrium, the concentration of hydrogen ion is going to be what? Is going to be this one you are seeing here, which is 0.005. So that shows that I'm going to consider of hydrogen ion to be equal 0.005. Then once I have hydrogen concentration, I can actually get what? Hydrogen ion, and that's the concept of hydrogen ion is going to be what? It's going to be 14, right? Actually, it's going to be 10 raised to power 14. Sorry, we're going to have it to be 10 raised to power minus 14, right? Divided by what? Hydroxide ion, which actually was 0.005, and this is going to be equal 1 multiplied by 10 raised to power minus what? 14 divided by what? I'm going to have 5 multiplied by 10 raised to power minus 3. So from there, let's just carry and separate. We're going to consider the hydrogen ion to be equal 1/5, then multiply what? 10 raised to power minus 14, right? We're going to have plus 3. So we're going to have this to be equal 1/5. 1/5 should be approximately, let's see what we're going to have it to be. That's actually 0.2. 1/5. So we're going to have it to what? 0.2. Then multiply what? 10 raised to power minus 14 plus 3. As you can see here, is actually what? Minus 11. So we're going to have this to be equal 2.0 multiplied by 10 raised to power minus 12. So this is going to give us molar. This is going to give us the concentration of hydrogen ion, right? So the concentration of hydrogen ion in what? In 0.05 molar NaOH is what? Is actually what? 2.0 multiplied by 10 raised to power minus 12. While that of hydroxide ion is actually what? This 0.005 that you are seeing. So that's just about what this question. If you enjoyed this video, don't forget to like, share, and at the same time make sure you subscribe. It's very, very important. Please kindly subscribe. Thanks for watching.